Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Hakim Irfan bin Ahmad Firdaus and my friends Loman Hakim bin Sahibi, Muhammad Haziq Irfan bin San Haji and Nial Ivan Romani. And today we would like to share to you guys about our project, which is force and factor of safety analysis from actual structure. Hope you will like about our project. Thank you. For the introduction, in this task, out of 3 structures that we are given to our lecturer, and we have to choose one of it, which is the first one, bridge, bicycle frame and engine hose, and we are decide to make analysis of bicycle frame. The bicycle is a common mechanical structure used for transportation, sport and recreation. It consists of several key components, including the frame, wheel, pedals and chain and the handlebars. The bicycle frame is made of steel and designed to withstand various loads, including the rider's weight, dynamic force during the motion, and impact from uneven terrain.
For this part, this is the data assumption for the truss structure. The diagram below it is shown is the body dimension. We assume that the material that used are steel with the yield stress of 200 megapascal and allowable stress with the safety factor is 100 megapascal. The cross-sectional area is equal to 150 millimeter square. The load that applied at the joint D is 800 Newton, and we assume that the geometry is to be symmetric with the L is equal to 2.4 meter and the load at the midpoint. This is the free body diagram for the overall structure with label as A, B, C, D and E, where D is where the load are applied.
This is our free body diagram for each joint. It is decided that the methods of each joint will be used to determine the force of each member present in a truss structure. For FBD at joint A, we assume the acting force for AY is 5.26 Newton. The angle for FEA is cos 50 degrees, FDA cos 80 degrees, and FDA sin 80 degrees plus FEA sin 50 degrees. For FBD at joint B, we assume that the force for BY is 11.58 Newton. The angle for FCB is sin 18.30 degrees. FDB cos 40.67 degrees and FDB sin 44.67 degrees plus FCB cos 18.30 degrees. For FBD at joint C, the angle for FBC is sin 71.70 degrees and FBC cos 71.70 degrees. For FBD at joint D, we assume the force for DY is 12.19 Newton. The angle for FBD is cos 46.67 while the others are FED cos 5.40 degrees, FAD cos 80 degrees, and FED sin 5.40 degrees plus FBD sin 46.67 degrees plus FAD sin 80 degrees. Last but not least, FBD at joint E. The angle for FAE is sin 50 degrees. FDE sin 5.40 degrees and FDE cos 65.40 degrees plus FAE cos 50 degrees.
Next is equation of equilibrium. Sum of moments at A is negative 800 times 1.2 plus force RE times 2.4 equals to 0. Then RE we got 400 Newton. Next, sum of vertical forces is force RA plus force RE equals to 800. And next we get RA equals to 400 Newton. So for the forces, we only show simple calculation for member force calculation using method of joints at joint A. So some vertical forces Fy equals to 0. FAB sin 60 degree equals to 400. So we get FAB equals to 462 Newton, which is compression force. The next sum Fx equal to 0, which means horizontal forces. We get force AE equal to force AB cos 60 degree, and we get 231 Newton, which is tension. For each member forces is AB is 462, compression AE 231, tension CD 350, compression BC 520 tension, and DE 520 tension. Next, maximum allowable force and safety factor. For Fmax equals to total allowed force times A, and equals to 100 exponent C times 1.5 exponent negative 4, and we get 15,000 Newton. And these force are below, all force above that have been calculated is below this limit, so the structure is safe. And for safety factor, we take for member CD equal to SF equal to forces max over F actual, and we take 15,000 Newton over 350, and the sum is 223.08. And for this number of safety factor is very high, and it indicating conservative design. And for conclusion, the bicycle frame model as a truss is structurally round, and all internal forces are within allowable limits. The safety factor across all members exceed the minimum recommended value, indicating the design is conservative and reliable.